Hi guys, this is the second video on 11D. We're on page 107, and we're going to continue on with these rational expressions with unlike denominators, but on this page we're actually going to have some variables in the denominators. The examples that we did on page 106 all had numeric denominators. So this isn't going to be that much different. Well, yeah, maybe it is. So first of all, again, reminding you that we need to find the LCM, the least common multiple, between our denominators, and that's going to turn into the LCD that we're going to use when our denominators are not the same and we have variables. So the LCM, just to remind you, we start with the prime factorization. Well, the prime factorization of a squared is a squared. Prime factorization of 3a is 3 times a. 3 is a prime number, and we just bring the variable in like it is. The LCM, you take every base that you see. So I see a 3 and an a, and you just write each base one time, but you take the highest exponent that you see. So 3a squared is going to be our common denominator. So this is what our shell looks like. We ask ourselves, okay, in this denominator, in a squared, what do I have to multiply it by to get to 3a squared? And of course, that's just a 3. So if I multiply a squared by 3, I have to multiply the numerator by 3 also to make that clever form of 1. In the next fraction, 3a, to get to a squared, I have to multiply by a. So I also have to multiply the numerator by a. And that's what I have. Single fraction bar. Clean it up. Distribute. 3a plus 9 plus a. Go ahead and simplify your numerator before you do any canceling, top and bottom. You cannot cancel until you have simplified the numerator and factor it. So what do we have here? We have 4a's plus 9 over 3a squared. So we don't have any factors that we can pull out of 4a plus 9 and cancel with anything in the denominator, so this just ends up being our answer. Let's look at this next example. This one has got 3 fractions as well, and it's got denominators of the ghostly 1. So I'm just going to kind of rewrite this so you can see what I'm doing as we go along here. So the common denominator is prime factorization 1, 1, and y minus 1. So our LCM, which turns into LCD, is y minus 1. So all of these have to have a denominator of y minus 1. So I start out just writing my shell here. I'm noticing this negative sign, but that's all right. If there's more than one term, I'll distribute it. So I go to the first fraction. I ask myself, how can I get from 1 to y plus 1? Well, I need to multiply by y plus 1. So I'm going to multiply the numerator that's already there by y plus minus 1 also. What about this second fraction? The same. He has a 1 in the denominator. I need to multiply him times y minus 1. So I have to do the same thing to the numerator. 1 times y minus 1. And this guy, I don't need to multiply him by anything. He has the common denominator, so I'm just going to bring this 3 down as it is. Again, I'm going to need to write a single fraction bar. I'm going to need to distribute. So that's y squared minus y plus y minus 1 minus 3 all over y minus 1. So when I collect my like terms, these two y's cancel each other out. That's minus 4. So I have y squared minus 4 over y minus 1. Now, you might notice that y squared minus 4 is the difference of 2 squares. So you could write it y plus 2, y minus 2 over y minus 1. And that would be acceptable as well. There's really no need to do that because there's nothing in here that will cancel with what we've got in the denominator. So I probably would just abandon ship right here and call it good. All right, let's do 2 more examples, C and D. All right, now we've got denominators that need to be factored before we find the LCD. So the U plus 2 looks okay, but when I look at the 3U plus 6 on the bottom, I need to factor out the GCF, and this is why we've done so much work on pulling out GCFs. Because when you do that, you notice that you have a U plus 2 factor here and here. It's going to be part of our common denominator, but we're not going to write it twice. So our common denominator is going to be the 3 and the U plus 2. Okay, so to get from here to here, I have to multiply by 3, so I have to multiply the numerator by 3. To get from here to here, I don't have to do anything. This is the common denominator. So the U plus 11, U plus 11 comes down, and it's just fine. Single fraction bar, 3 times U plus 2, distribute, 3U minus 3 plus U plus 11. See what we've got here. So 3U plus another U is 4U plus 8 over 3 times U plus 2. And now you might notice that we're not finished factoring this numerator. We can factor out a 4, and we have U plus 2. And in the denominator, we have 3 times U plus 2. This U plus 2 is a common factor. We can cancel them out. And our answer for this problem ends up being 4/3. Kind of cool, huh? This is fun, actually. Lots of fun. All right, one more. Actually, we're going to do this one on the video check. I think I just see that set up. So I'll stop this video here, and we'll pick it up on the next page. Thanks for watching.